How have Python application deployment methods evolved? Imagine building a Python application today and deploying it feels like a smooth ride, but it wasn't always this way. Over time, deployment methods have changed a lot, making life easier for developers. Let's walk through how these methods have grown from simple to sophisticated. In the beginning, deploying a Python application was pretty manual. Developers would copy their code files directly onto a server using file transfer tools. They would then install dependencies right on the server, often with command line tools, and restart the web server to see changes. This process was quick but could lead to errors. If dependencies conflicted or if a mistake was made, fixing it could be a headache. Also, rolling back to a previous version was complicated because files were overwritten directly. This era is often called the File Transfer Protocol, or FTP era, because files were uploaded directly to servers. As applications grew more complex, developers started using version control systems like Subversion and later Git. Instead of copying files manually, they would check out the latest code from repositories. This made tracking changes easier and helped teams work together. But dependency management was still tricky. Developers used virtual environments to isolate dependencies, but setting these up on servers was still a manual process. The next big step was the introduction of tools like pip and the requirements text file. Developers listed all dependencies in a text file, and pip could install everything automatically. This made dependency setup faster and more reliable. Still, installing dependencies on the server was manual, which slowed things down. To automate deployment further, developers used scripting tools like Fabric. These scripts could connect to servers, create virtual environments, install dependencies, and deploy applications with one command. Another advancement was the use of symbolic links to manage different application versions. Instead of copying files or changing directories, developers created links pointing to the current version. When a new version was ready, they updated the link. This made switching versions quick and easy, and rolling back was just a matter of changing the link. As teams and applications grew larger, automated pipelines called continuous integration and continuous deployment, or CI/CD, became popular. These pipelines automatically tested code, built packages, and deployed updates. Tools like Jenkins, Travis Continuous Integration, and GitHub Actions helped set up these pipelines for Python projects. This automation reduced errors and sped up releases. Packaging also improved. Instead of just deploying source code, developers created installable packages. Tools like Pinsys, Py2x, and Py2app allowed creating standalone installers for Windows, macOS, and Linux. These installers bundled the application, dependencies, and even the Python interpreter, making distribution much easier. Containerization with Docker changed everything. Docker packages an application and all its dependencies into a container that runs the same way everywhere. This means developers can build once and run anywhere, whether on a developer's laptop, testing server, or production environment. Containers also make scaling applications and managing multiple services straightforward. Today, deployment often combines these methods. Developers use CI/CD pipelines to automate building and deploying, package their applications for distribution, and use containers to ensure consistency. Automation tools like Ansible, Salt, Chef, and Puppet help set up and manage servers efficiently. This evolution has made deploying Python applications faster, more reliable, and easier to manage, giving developers more time to focus on building great software.